Hi, I'm Sam Aaron, and I'm here to talk to you about how you might be able to use your coding skills or learn some coding skills to become expressive. What on earth do I mean by that? Well, typically you learn to program to build business apps or web apps or as a career, which is a great thing to do. And many of you out there may be already doing that, and that's brilliant. But there are many, many others who yet to really touch code, to become familiar with it, to understand what it is. And for them, particularly, I think we need to find ways to reach out to help them to understand what code is and what it can do. And I think building business apps is one thing, but I think that being expressive with it, using it to share your feelings and thoughts in new ways, I think actually is a really powerful and wonderful and yet to be really fully explored aspect of programming. And that's really what I've spent most of my life exploring myself. And all the tools I've built, all the things I've learnt, I've tried my best to compact together, to squish into a little small thing that I can give to you to play with. And the latest version of that is a tool called SonicPy. And this is an open source, fully free tool that lets you write text in the same way you might write in a Word document, but it has a special button which you can press, which then turns that text, that code, into music. And we're going to see how that can help you get started to program. But also, if you're a professional programmer, this is still a really interesting tool for you because it has concurrency, has event data stores, it can do distributed programming, it's deterministic, it's got all sorts of cool fancy features that let you really do some really explorational, advanced things with your skills. And that's actually really what this is all about. It's about creating an equivalent of a guitar. And why would I talk about guitars? Well, think about a guitar. It's an object you can pick up, that most people can pick up and most people can play and strum, hit all the strings. So starting the guitar is actually quite a simple and easy thing to do. But the reason why most people pick up a guitar probably isn't because it's a beautiful object made of wood and looks lovely and shiny and polished in the shop. It's probably because they've seen their favourite artist, Jimi Hendrix or Taylor Swift, perform. And they've seen this weird wooden medallion around their neck and they've said, what on earth is that wooden thing around their neck? I need one of those. And their friends have said, that's a guitar. And so that's why often they've picked up a guitar, because they've seen motivational and aspirational figures using that instrument to do amazing things. So I think that when we're thinking about creating experiences with code, we need to think about both of those things simultaneously. Firstly, making sure it's super simple to get started, and we'll see hopefully how that's the case with SonicPy. And then secondly, to make sure that if you practice and put in the effort and learn and study and work hard, then you can be rewarded with being able to do things that you could only dream about before. And I think that's true with the guitar, and it's also true with SonicPy. And I'll be showing you a little bit of that today in this workshop, but really this workshop is about getting started. But at the end of the conference, or towards the end of the conference, I'm going to deliver a performance, and that performance is going to be my demonstration to you of what you could do if you practiced. Now that performance is going to be pretty special. It's going to be the first time I'm ever going to live code a performance that also includes your work. So we're going to see at the end of this workshop a call to a challenge to call to you to produce your own small little riff, audio riff, when I'll show you how to do that you can then use to obviously play yourself, but then you can send it to me. There's going to be a link below in this description of this video of where to send that little snippet of text. It'll be like 8 lines of code, nothing complicated. And then I'll be able to collate and bring those together, and depending on, if I get a million of them, I'm not going to be able to use all of them, but I'm going to use as many as I can and integrate them with my performance and show your names and to work with your code as much as working with my own code to make it more of a collaborative performance. So that's going to be quite exciting. So today we're going to get to understand the beginning and how we can get started, and then the performance is going to really show you hopefully what you could achieve and give you hopefully that motivation to really to learn this thing and to become the DJ of the future, really. That's how I'm going to describe it. I mean like the DJ of the future, right? So here I am in performance mode, and I've got my code on the screen, and I've got my crazy visuals and stuff, so you can do this kind of thing. But what you're really seeing is this code here, and this is the SonicPy editor, and this text ed environment is just a text ed environment. I can type words, and those words have to mean something to the environment. So this crazy load of letters does obviously means nothing. So if I try and run that program, that doesn't work. So we obviously need to know the very basics of this system. And so the basic program you can write is the word play and choose a number like 70 and then hit the run button. And it creates a beep. So this is a complete, fully functioning, syntactically valid, semantically correct program. And this is a kind of program that many children all over the world who have used SonicPy to learn to start programming have all written. And this is lovely. I mean, it's a great way of just getting started where you have a very simple thing to write and you have immediate feedback. You're not looking through tools of logs or where things are. You're just hearing a beep. And you have control of that beep. I mean, you can play some options. I can play that beep louder or quieter. I can play it up too. I can choose how high or how low that beep is. And so I have the ability now to manipulate the pitch, the how high or how low that note is by changing this number. For those who are interested, the units of this is what we call MIDI notes. They kind of map on to notes in a piano. So each whole integer that goes up is the next note, including the black notes on a piano, or if you go on the fretboard of guitar, it's one rung up the fretboard. So we can see that. You can hear that. But this is interestingly, this exact note you're hearing now is determined and defined by Western standards. So we're hearing what Western orchestras might play for note 55. And that just happens to be a decision that has been agreed upon, and it only really holds in the Western traditions of music. And if we break out of those, we really start to explore all sorts of interesting ways of choosing how high or how low your note is. And so SonicPy, although it makes the Western tradition easy by using integers, it does give you access to playing fractions of notes. So you have essentially floating point access to the range of notes you can have. So you can play essentially any note you can perceive, you can play with the system by just choosing the right number. And you don't have to stick to whole numbers. You can stick to floating points if you want to break out of the Western traditions, which I think is pretty exciting. So far though, I've just shown you one line of code. What about 2 lines of code? Let's play note 70 and then play note 75. Now, the way to learn SonicPy is to write the code, not press the run button, just imagine what it sounds like. So I invite you at home to look at that code and to imagine what it might sound like. Note 70 and then note 75. Ooh, they played at the same time. Now, you might have expected it to play note 70 and then note 75, and actually in the early days of SonicPy, when I first created it, that's exactly what it did, but it did it so fast after one after another you couldn't hear it, just as the computer is crazy fast at interpreting the instructions. But actually in the more recent versions, this is actually played sample accurately at the same time, so really precisely at the same time, because timing and music are something which really work and are important and are necessary for each other. And so SonicPy has extremely good timing semantics. That's really one of its core skills. So if we want to make a melody, we break it out by adding a sleep command, and that then allows us to tell the computer to go to sleep between note 70 and note 75, and this way we can now make our melody of whichever notes we want. Let's go for 82. Lovely. Now, this might be fun. It is fun, I think it is anyway, and but it might be fun to you. But what I think is really interesting is that this is likely to be fun to many more people in your lives than talking about, I don't know, Nginx configuration, or enterprise Java service beans. Are they still a thing? No, probably not. What else might you talk about? JavaScript promises. I don't know. Whatever the latest technology, the latest whiz-bang thing is, the chances are most of the people in your lives who aren't programmers are going to struggle to follow along and be interested. Whereas if you talk about music, actually, I found it's much more easy to have that conversation and to keep them engaged. So I think this is more likely to interest a broader audience. And I think this is the goal of Sonic Pi. So Sonic Pi is meant to be two things. It was meant to be a musical instrument. I was talking about guitars, talking about the fact you can get started and how easy it is to get started with a guitar or a piano. Here, hopefully, you can see that this is also easy to get started with. We have access to pretty much any melody you've ever heard or will hear with two commands: which note to play and when to wait, how long to wait for the next note. But, and this is a crucial thing, this also gives you access to doing really sophisticated and really interesting detailed music. So we can take any of the synthesizers here and bring them all in and mix them together and all sorts of events and sounds and have a lot of fun. And we can have access to all of that here as well. And all you need to do for that is to start adding more code, essentially, to explain the different kinds of things you might want to do. So, what do I mean by that? Let's play note 70. A bit more code is the release command. Oh, get that correct. That's how long the note lasts for. Or I could attack. That fades it in. Or I could fade it in and have no release. Oh, suddenly cut off. Or I could change the synthesizer. Let's change it to profit. That actually works much better at maybe... Some of you might want to know why I'm doing this subtraction here. Actually, you can obviously just throw some maths in there, but 12s in Western music is an octave. So 3 times 12 is 36. That's going down 3 octaves. Just saves me having to do that mental arithmetic in my head. So we have now ability to play these notes. Let's go for release 8. Let's make it louder. Make the cutoff 70. So here I'm able to make kind of like drone music, essentially, by layering the sounds on top of each other. Probably for this kind of environment you want to be in sort of dark mode, so that you're in some sort of like a nightclubby environment. And you're playing these sounds. So what we've got here essentially is multi-threaded environment. So each time the code goes pink, it creates a new thread of execution and gives that thread the code that you can see on the screen to execute. And it runs through that code from the top to the bottom, and when it finishes, it automatically stops that thread, garbage collects it, tidies all the things, all the resources it's been allocated, and then frees it so you can have another thread. Of course, that means you can have the multiple of these threads running at the same time, which is why you're hearing the sounds layering on top of each other, which gives you really a lot of interesting potential for drone music. But it also has a really other important aspect as well, because in Sonic Pi, well, you've seen already that we can do play. We can play multiple notes. We can wait between the notes. We can change the length of notes. We can change a synthesizer. Yep. And so this gives you access to a huge amount of music possibilities already. You can essentially compose your own piece of music. You can change the sound as it's being played. You can change the length of the sound. You can change the qualities of the sound with this cutoff and other things. And each of these synthesizers has documentation describing all the different things it can do and all the options it supports in the documentation system already there. So you have a lot of fun and power there. But there's there's 2 more really actually quite exciting things to show you that really can get you started and advance pretty quickly. The second one is, well, obviously you can use control structures. That's not even a thing to explain. Look at this. 8 times. So I'm going to play that note, wait for a small amount of second. Here's an eighth of a second. So let's play it 75. Or I can do a scale, for example, E3 minor pentatonic. I can choose a random note. It's pretty cool. So this is actually, this code here is pretty much the start of the challenge, which we'll get onto in 10 minutes or so. But so just to get you in your head, this is the kind of code I'm going to hopefully ask you to write. But listen to this. But first of all, notice that it plays the same thing every time. So what we're hearing, even though we've got this word choose, which you think might be to do with randomization. Maybe I've got like a bag of letters, I'm playing Scrabble, and I'm pulling out random letters. If I pull out 8 letters, and then put them back in again and pull out a different 8, I'm going to get a different 8 letters. But yet with Sonic Pi, I always get the same ones. And that's because by design, Sonic Pi is what we call deterministic, which means that it always does the same things every time it runs. And that might sound limiting, like, oh, but I want my randomization to always be random. Surely that's the point of randomization. Well, actually, you want probably 2 things. You want it to feel random, so that you can try new things out. And we can get that feeling by changing what we call the random seed. So by default, the random seed is 0. What we heard before is the same. But actually, by putting some random number in here, we get it to make different choices. Or this number, or this number. Now, if we like that, we now have the ability to reproduce it. So the cool thing now is that if you were to take this code and copy and paste it, or just type it out again into your version of Sonic Pi that you've downloaded from the website, you will hear exactly the same notes played in exactly the same way. So that's the second benefit of a deterministic system, is it allows us to share the code and to know what the people who play that code are going to hear. That turns out to be really useful for collaborative jamming and for composing together with friends in a distributed fashion. Which means that code that you upload to GitHub and to a gist, say, that you copy and paste in Sonic Pi, you know you're going to hear what the person who created that intended you to hear. That's a critical thing. But then another thing to show you is the effects. I can use an effects block. Well, what do I mean by that? Well, here we have this do end, which describes the iteration. Where to start the iteration, this do. So I'm going to do something 8 times. And this is what I'm going to do. I'm going to do everything between the do and the end, which means all this code, any code that was written between these 2 words, do and end, will be repeated 8 times. We can have another do end block around that. You can see it's nesting it, and we can do something else with that code. We can use with effect. Let's choose reverb. Let's make sure it sounds like it's in a big room. That's nice, isn't it? Or I could choose echo. I could choose crush or bit crusher. And there's a whole ton of these effects that I can play with, flanger. Which can change the quality of the sound. So these are kind of like guitar effects pedals that you might buy from a shop. They're about, I don't know, $100 each. You buy 5 of them, chain them together, and then you plug your guitar ends, and you can twiddle the controls, and you can change the sounds. Well, in the same way with that, you can nest these effects inside Sonic Pi. So I can play it through crush, and then through flanger, and then I can play that through reverb. And we could nest these things together. So this play sound goes through the crush, goes through the flanger, goes through the reverb, and then you hear it. And then so we're able to combine all these effects together. So this is a really cool technique for being able to change the quality of the sound in the same way a guitarist can change the quality of their guitar by using these effects pedals. So now we've learned how to play notes. We've learned how to play any note you can hear by using floating points. We can wait between notes. We can make any melody. We can change the sound of the sound by changing the synthesizer. And also we can change some of the options of the synthesizer, which are basically like these kind of knobs on this synthesizer here, but they're just words, key value pairs, an associative map, as it were, of control values which are passed to as a parameter, an optional parameter to the function play. We can then use things like control structures, like iteration, to do something 8 times or 7 times or 800 times, how many times you want to do it, repeating this around here. And then we're using lexical closures or so-called effects blocks to then wrap around your sound code to change the sound. So this means that the play of the chip lead sound, which is playing here, is going to be crushed, flanged and reverbed. So you're going to get this new kind of sound. And you're obviously changing the order of those will change the sound, and removing them and adding them will change it around. So that's a lot of fun. And this is essentially what I'm hoping you might come up with the challenge, which we'll talk about in a moment. But before that, I'd like to show you one more thing, which I think is really quite fun. And that is being able to live code. So everything we've talked about so far is sort of a compositional mode, where we're writing a bunch of codes, changing the sounds, changing the timing, pressing run, hearing the sounds. What actually is also fun to do is to make a loop. So let's play a sample. So we can also play pre-recorded sounds. So let's play this loop amen break. Play it quite loud. We can beat stretch that to match 2 beats. We can create a loop. We can seek for the 2 beats, and now we have an endlessly repeating drum break, which is pretty cool. So let's just park that for 1 second, and let's do it again, but with a different sample. Let's play the bass drum house sample, and let's seek for half a beat. Cool. Now I was amazed actually by the number of times I've seen people write this code. So let's for effect, let's do this. So now we have this code here. Again, as we saw before, the way to learn Sonic Pi is to read the code, imagine what it sounds like in your head, and then press the run button. So just spend a moment. You heard the kick drum, you heard the amen break spinning round. Let's hear what they sound together. Oh. Where's the amen break? Well, if you're a professional programmer, and this is an interview question, why can't you hear the amen break? I'm sure some of you are screaming out to me, it's because you've got a single threaded application and the loop is infinite and the program never exits a loop. Well, okay, what do you mean? So let's think about this. The code starts at the top of the program and works its way down. That's typically what happened in most traditional programming languages. So we get to this loop. Here's the first thing, really. These 2 lines here are blank. And this means loop forever. So we play our sample, our bass drum, we wait for half a second, and then we loop around. Play a sample, wait for half a second, then we loop around, and we loop around, and we loop around forever. And we never, ever, ever get down here. So that's a problem. So the solution to this is to use threads. Now they might be a nightmare concept that you sort of don't touch them, you get out your garlic and you hunt them away like vampires. But inside Sonic Pi, actually, threads are really nice and they're really friendly. And the way to use threads inside Sonic Pi is to use live loops. Let's call this kick, and let's call this drums. You give them names, and then you run the code. And you can hear that. I mean, actually, that kick drum's not loud enough. Let's make it a bit louder. The sample, maybe let's make that half speed. Get rid of the sample, turn it out. Let's change the cutoff of this drum. So, live loops have 2 cool properties. One is that they can play things at the same time, so this idea of concurrency. So this actually is completely natural in a band. Now you have a singer and a guitarist and a bass player. They will all play at the same time to make the band. But they do another thing actually, which is pretty critical, which is playing not just at the same time, but in time. So these 2 threads, the kick thread and the drums thread, are not just executing simultaneously, as you might imagine a traditional programming thread to do. They also play in time, which means that the kick drums kicks exactly the same time as the amen starts, and no matter how long they play, they don't drift out of time, they don't drift back in time and mess around. There's none of that. Everything's completely hard synced. I mean, I've spent a lot of time and effort actually behind the scenes making this work. A lot of my time has gone into making the timing system as precise and deterministic and accurate as I can. I'm still working on that as well. So we had the concurrency, but there was one other thing. We could change the code as it runs, and that's a critical thing. This is the sort of the opening gateway to what we call live coding, being able to play the code and modify it as it runs. And when you see me perform in my performance, you'll see me writing a bunch of these live loops. They're all doing a simple thing, but a few of them together combine to make something interesting and complicated. Just like if you took out a bassist of a band and just played them on her own, she's probably going to play quite a simple riff. And the guitarist, she's also going to probably play a simple riff, but put them together and it sounds much more interesting. That's the same with live loops. Each one of them probably only does a simple thing, but combined together, you get really cool effects. So this really is the opening point to exploring more of what Sonic Pi can do. You can use it to get started. You can use it to get started with 6-year-old children, anyone who can essentially type and read with play and sleep. You can start advancing into different sounds, controlling those sounds, adding effects, using iteration, and then also starting to live code with live loops, which let you play multiple things at the same time. So one live loop doing the bass, one live loop doing the synth riffs, one live loop doing the drums, and then bring them all together and modify them as they're running to make that performance. And if you want to get more started, you want to learn more about this, you want to actually open up the tutorial. So you just click on the help system, and you can see here there's a full tutorial built in. This is also available on the website. If I go to the website, you can actually see that I can click on the tutorial section and I can work my way through the website as well. So you can read everything I've shown you and a lot more on the tutorial. But let's finish with a challenge. So I hope that you might be interested in getting started and also possibly contributing something into my performance, so I can bring in your code and use it to make your sounds come out of the speakers of my performance and integrate it with what I'm doing. And so for that, rather than just ask you to make anything and figure out a way to somehow stitch it together in a way that makes sense, I'm going to ask you to work with the E3 minor pentatonic scale. Now, if this doesn't mean anything to you, don't worry. This is kind of like a color palette. If you're designing a website, your designer might give you a bunch of colors and say, only use these colors, please. This particular red, this particular green, this particular yellow, or whatever the colors are. And as long as you stick to those color palette of colors, it's going to be fine. And this scale is essentially a color palette of notes. It's just a list, actually. I can print that on the right-hand side, and you can actually see here it's 52, 55, 57, 59, 62, and 64. They're your notes. So if we'll stick with those notes, and then we can do anything with them. So I'm going to spend the next 1 minute 30 giving you as many ideas as possible. And as long as you're working with these notes, it doesn't matter. Just throw it at me, and there's a link below to submit your code. A few lines of code. So a valid submission would be, let's give this a name, notes, and let's do 7.times do play notes.choose sleep for 1 second end. There we go. There we are. That's a valid solution. So if this could be a solution, just take this code and submit it to the link below. But what I would recommend is start with something like this and then just slowly tweak it. What happens if we make the release time short? Yeah, and add some reverb. Maybe change the room size to 1. Maybe use synth TB303. Maybe cut off 70. Maybe a random cutoff between 70 and 130. Remember, all these things I'm showing you are in the tutorial if you want to learn more. Yeah, that's nice. Maybe choose a lower E. depending if you're making a bass line or a melody riff. Maybe even choose a different timing. Or randomize the timing. All these options are yours. I'm looking for a short piece of code that uses the E3 minor pentatonic scale, whatever synthesizers, whatever timings, whatever release times and cutoffs and all the things you want to play with. Choose your own, play around with it. It does not need to be complicated. And then submit it to the link below, and I'll bring them all together and bring them into my performance. Okay, so that's me done. Thank you so much for watching my workshop. I hope that this hopefully gets you started, really excited hopefully, to understand the true potential of code is not just for making business apps. It's also for humans expressing themselves in new ways. And music is a beautiful medium for that expression. And I really hope that some of you might start to your adventure of exploring how you might express yourself with code and music using Sonic Pi today. And I really hope that one day in the future I can come and see some of you perform and come to your gigs and crazy dance like a mad person who dances to people who make music with their coding system. I'm sure that happens to everybody. Anyway, thank you so much for watching, and I hope for you to see you all around soon. Thank you. Bye.